All right, in this question, we're gonna solve for the solubility of magnesium hydroxide in water at 25 degrees. Now remember, K can change depending on the temperature, but here we're looking at 25 degrees. And so we have this giant list of KSPs at 25 degrees for all these different molecules, these ionically bonded molecules. And so today we're looking at this one right here. Not especially soluble, though more soluble than something like this, 5.61 times 10 to the minus 12th. Now you might think, how is this going to tell me when I don't have any concentration? So what we can do here is actually solve for the molarity. How many moles per liter? So if we have more liters, we can handle more moles. If we have, if we want to put more moles in, we can add more liters. So we can figure out how many moles per liter will fit in here. So it's just kind of a generic, if I have 1 liter, this is how many moles. And we're actually going to take that moles and go to grams because it asks for grams per liter. So if I have liters, I could be in the lab and be like, okay, I can add this many grams and it should all dissolve. So let's take a look. So how are we going to do this? First, let's write our equation. So MgOH2, which is a solid, gets put into water. It'll be at equilibrium when it's at that saturation point. So we got magnesium, which is a 2+, and we got OH, 2 of them, which is aqueous. Now, we're using KSP, which is an equilibrium constant. So we have an equilibrium expression, and we don't add our solids. So our equilibrium expression is KSP equals so that's what we're looking for. Now, how can we do this? We're going to assume there's no products. There's nothing, we're not adding it to a solution that has some of these ions on, which we'll look at later. So there'll be a video on that as well. But so we have 0. So let's make an ice table. And we're going to say we start with 0. We're not going to add our solids. We're going to add X. We're going to add 2X. And now I can set my KSP equal to this. All right, 2x squared is 4x squared times x. So we got KSP, which is 5.61, is equal to 4x cubed. Okay, so the first thing I'm going to do, I'm going to solve for x. Now, maybe a better way to put this, and you see me do it in class, is to make these s's, right? Because we're solving for solubility. So making it an S kind of reminds us, oh yeah, we're solving for solubility. And so let's divide by 4. So 5.61 raised to the 12th, negative 12th divided by 4 is 1.4025 equals S cubed. And now I can take the cubed root of that or raise it to the 1/3 power, and I get the solubility is 1.119 times 10 to the minus 4th. Remember, concentration is molarity. So now we got moles per liter. And now we can say, and so that tells us the concentration. Now this is a 1 in front. This is right, a 1-to-1 ratio. This is S. This is S. So we have a 1-to-1 ratio. So that tells us that that is the concentration over here. We can multiply it by our molar mass. Moles per liter times how many grams? We got 58.32 grams. So we get 0.0065 grams per liter. So not a lot can go in there and be soluble. So let's plug that in. Okay, I usually put a 0 and I forgot. So there we go. So we're trying to figure out the solubility. And so this last step, we're multiplying by the molar mass of the whole compound when we're dealing with a 1-to-1 ratio of the ions to the compounds. What is that molarity?